which will be on a very critical topic of the role of composites in hydrogen manufacturing. It will be by Mr. Ketan Pednekar from Scottish Development International. And he probably is available online now. Yeah, there he is.
Hello.
Yes, sir, we can hear you. Hello.
Hello, can you hear me now? And
Yes,
can you
sir.
see the slides?
Yes, sir, loud and clear. You can start. Welcome, sir. Please.
Yes, thank you very much. I hope you can see the slides. So let me start my presentation. First of all, let me thank all of you, the organizers as well as the audience, for giving me this opportunity to share my views on role of composites in the hydrogen economy. My name is Ketan Pednekar, and I'm a trade specialist for energy transition for Scottish Development International based in Mumbai. So this is the agenda for my presentation. I'll first give a brief about Scottish Development International. We'll then talk about why hydrogen. We'll see hydrogen demand projections and opportunities for composites in the transport sector. We will briefly see the research opportunities in this sector and then conclude. First, a bit about Scottish Development International. Scottish Development International is the international arm of Scottish Government's Economic Development Agency. So what we do, we assist Scottish companies to trade overseas and try to attract inward investment into Scotland. Now, Scotland has excellent ecosystem where research institutions and industry work together to solve industry problems and develop innovative solutions. And there are many collaboration opportunities to optimize or to improve composite manufacturing between Indian institutions or industry and Scottish institutions. So if any of you are interested to explore these opportunities, please feel free to reach out to me with specific details of the research area or the problem statement, and I can connect you to with the relevant experts. Now, why are we talking about hydrogen? As we all know that climate change is real. According to IPCC special report on global warming, higher temperature thresholds will adversely impact an increasingly larger percentage of life on Earth, with significant regions, ecosystems, and species getting affected. So we are already experiencing rising sea levels, more extreme weather, more frequent wildfires, heat waves, increased droughts, etc. And all these events could be attributed to climate change. World over, the governments have realized this. They are realizing the importance of climate emergency and net zero, and they've set targets for reaching net zero. Scotland is committed to reach net zero by 2045. UK will reach it by 2050. Our own Honorable Prime Minister has set a target of 2070 for India to reach net zero. Now, hydrogen is a versatile energy vector which can be used for achieving net zero in some of the very hard to abate hard to decarbonize sectors such as steel, cement, industries, and transport. So many governments are giving prominence to hydrogen in their net zero strategy. As you all know, it's the lightest and the most abundant element in the universe. So India also has declared a national hydrogen mission, and growth of hydrogen economy in India will certainly be very rapid if government implements the industry friendly policies and takes bold initiatives. Now, the global hydrogen demand reached around 95 million tons in the year 2022, divided mainly between industry and refining. However, as the world aggressively tries to decarbonize, transport sector, which accounts for almost a quarter of the world's emissions, is an important target area. Sales of battery electric vehicles are growing fast, but the driving range, recharge time, rush for rare earth materials are some of the challenges for growth in this sector. Especially for heavy duty transport with long range travel, batteries are not currently a viable option. Here, hydrogen fuel cell trucks are increasingly becoming more Besides, world needs all the solutions that make economic sense to reach net zero. So even the passenger vehicles having long range and rapid refueling capability will become attractive to customers in future. So there are many such vehicles already running in California, South Korea, China, and Japan. China sold around 6,000 electric vehicles, FCVs, South Korea around 4,600, California around 3,000, and Japan around 400 FCVs in the year 2023. So, however, as more and more hydrogen projects come online, more and more refueling infrastructure is in place, the sales could really take off. If you see International Energy Association's projections by 2030, the hydrogen demand is expected to reach around 150 million tons globally, out of which around 9 to 10 million tons will be used in the transport sector alone. So this will create a huge demand for mobile storage of hydrogen. So considering this demand, 10 to 15 million cars and around 500,000 trucks will be on the road by 2030. And considering automotive type 4 tank requirements for these vehicles, considering 12.4 million passenger cars and 0.5 million trucks will be around 15 to 16 million tanks if you consider 5 kg tank as a standard. Of course, this target looks very, very challenging. It is very unlikely to be achieved. Uh, Hydrogen Council, which is another CEO, global CEO-led initiative that brings together leading companies with a united vision for hydrogen. They have a more realistic outlook, anticipating around 4.5 million FCVs by 2030. So even if you consider this figure, the hydrogen tanks for automotive purposes could be around 5.8 million tanks. So this is really a huge opportunity for Type 4 cylinder manufacturers. Now, European Union is mandating 30% emission reduction by truck OEMs, which will force them to manufacture either electric or FCV trucks. It is likely that around 5% of the trucks manufactured will be FCVs. This means by 2030 in Europe, as much as 50,000 to 20,000 trucks per year will be FCV trucks. Now, Hexagon Purus, a Norwegian company which manufactures this composite cylinders, they estimate that there will be around 630% increase in hydrogen storage tank sales. They expect the revenues from the sales of these tanks to be $1.1 billion in 2025, which will increase to $7 billion by 2030. Now, Toray Industries T700 standard modulus carbon fiber has become the benchmark for Type 4 pressure vessels, storing hydrogen gas at a standard pressures of 350 to 700 bar and renewable natural gas at around 250 bar. So now Toray is expecting the demand for carbon fiber or pressure vessels to hit almost around 40,000 tons per year by 2025. And to service this expected demand, they are planning to increase the production capacity to 35,000 tons by year 2025. There is another supplier of carbon fiber, Hyosung, is planning to increase the production capacity to 21,500 by 2025. They're setting up a new plant in southern Vietnam. Now let's talk about the leading manufacturers. Hexagon Purus, they are the battery electric systems and vehicle type 4 pressure vessels and hydrogen systems for vehicles. They are the suppliers with a total capacity to manufacture around 50,000 type 4 cylinders from two sites, one in Westminster, Maryland, and one in Kassel, Germany. Then they have another Hexagon Agility, the company that produces type 4 carbon fiber composite for renewable natural gas at lower pressure, which includes the systems for truck, bus, and distribution applications. Another player, Faurecia, they first announced the development of hydrogen system for fuel cell vehicles in 2017. And they displayed 700 bar type 4 cylinder back in 2018. And after opening its hydrogen storage R&D center in Bavans, they've announced the contracts with Hyundai, Stellantis, and Renault Hogia to supply those composite cylinders. There's another player, OP Mobility. They manufacture Type 4 tanks and integrated hydrogen systems. It can produce around 150,000 Type 4 cylinders from its Belgium, South Korea, and France facilities. They're planning to add another 60,000 pressure vehicle capacity in Shanghai. Luxfer is one more major gas cylinder supplier from the UK. Uh, they are having, the products for 350 bar and for alternative fuels such as CNG and hydrogen. They are exploring 700 bar tanks, but the commercial products are not available at this time. Worthington is one more manufacturer. Its Austria plant is located um, in Austria, was commissioned in 2021, and they also acquired Portova composite cylinder plant in Poland in 2011. Then Voith is another manufacturer which recently received R134 certification in December 2023 for its carbon 4 tank 350 liter 700 bar type 4 storage vessel for hydrogen made using a Tau Preg system. So if we consider Hydrogen Council's figure, the transport sector itself is expected to see a very big growth, and more than 4.5 million fuel cell electric vehicles are expected to be on road by 2030. China, Japan, and Korea, along with Europe, are expected to lead the rollout of these vehicles. The growth in near future is expected in trucks, buses, trains, although passenger vehicles will also see more demand as the refueling infrastructure grows. This is a massive opportunity for composites for hydrogen storage in mobile applications. And as Type 4 tanks are lightweight, they are the preferred option in mobile applications, although they are much more expensive than the conservative ones. Now, French automotive tire one supplier for Russia and Plastic Omnium forecast production of 2 million hydrogen-powered vehicles per year by 2030. And of these, 1.5 million will be light duty and passenger vehicles. And Asia, will be the leader in FCV market with 70% of the market share. They claim that 40% of the value of the fuel cell systems is in the hydrogen storage tank itself, and 70% of this 40% cost is for the tanks, and remaining is for the valves and other components. Now, as mentioned earlier, road transport decarbonization is one of the critical aspects of reaching net zero. And today, hydrogen fuel cell buses are in the early stages of commercialization. The selling cost of these vehicles is not yet competitive, and infrastructure issues like lack of hydrogen refueling station network is a major constraint for the widespread commercialization of fuel cell vehicles. Toyota, Hyundai, Honda, they're the leading manufacturers of hydrogen fuel cell vehicles. All of them use Type 4 cylinders. The heavy duty market also has a considerable potential for hydrogen fuel cell adoption, even though it represents um, different operating conditions and driving cycles. These vehicles need higher power output, improved durability, and fuel efficiency. Light duty passenger vehicles are used for short and low speed journey, could be managed by electrical batteries. For the long haul heavy vehicles such as trucks and buses, they call for a higher utilization and are likely to require hydrogen. So many city centers now have set timelines for banning diesel power buses. So companies such as MAN, Scania, Hyundai, VDL, they have developed hydrogen fuel cell electric trucks. So fuel cell buses have attracted a lot of attention. Aberdeen in Scotland, they run a fleet of fuel cell buses for public transport. They have been a public demonstration tool and R&D source for the data. Many such projects are already implemented using government funding and support. So onboard tanks are typically mounted on the bus roof. Many of the buses use 350 bar storage, thus lowering the compression and tank costs. So Van Hool, Toyota, Hino Motors, Hyundai, Wright Bus, PDL Bus and Coach are some of the companies that manufacture these fuel cell buses. Now, apart from this, the high pressure tube trailers are also vital for hydrogen transportation logistics. So, for widespread rollout of this fuel cell electric vehicles, availability of refueling stations is the key. So, according to a Hydrogen Insights report, there will be around 10,300 hydrogen refueling stations by 2030. And the current infrastructure for transporting hydrogen to the refueling station is limited by the availability of hydrogen pipeline, which is almost non-existent. So it is only available for large scale industrial units such as refineries or fertilizer units. So here, the tube trailers, which can effectively become virtual pipelines, to transport hydrogen to the refueling stations from the production units within a reasonable distance, say around 160 kilometers. And these tube trailers are now increasingly developed using Type 4 cylinders, as shown in the picture. Now, trains, they are also a very good market for FCVs as they run long distances. And if a rail is to be decarbonized through electrification, costs around 0.97 to 1.3 million per kilometer. According to one 2017 report for Caltrain, it noted that electrification of San Francisco to San Jose commuter line using 22 cell trains, including the construction of hydrogen filling station, would cost around $1.3 billion. However, if you go for a conventional train with overhead contact systems, electrified, so it could cost around $3.1 billion. So there could be a savings of around $1.8 billion if you use hydrogen fuel cell trains. So the infrastructure for buses and trains are also relatively easier to develop as they come back to refill to the depots. So this is a very big advantage compared to the passenger vehicles that need huge refueling infrastructure development. As this market is also picking up fast, and the above picture is taken from Ballard Motive Solutions. It's a Scotland-based company, and they specialize in complete powertrain systems and fuel cell vehicles. And they delivered Scotland's first hydrogen train. Another famous example is Island Train by Alstom. And considering more such requirements globally, this segment is a great market for composite hydrogen storage tanks. The most preferred storage pressure for this trains currently is 350 bar. Now, shipping industry is also responsible for around 940 million tons of carbon dioxide annually, which is at least 2.5% of world's total CO2 emissions. And there is a lot of interest in greening some of these marine vessels. The pic which is shown is a proposed hydrogen-powered ferry in Orkney Islands in Scotland that will be operational soon. And there are very similar projects in Norway as well. Historically, for marine vessels, the focus was more on liquid hydrogen storage. However, increased interest towards compressed gas is seen in recent times. So in marine vessels, there is no one size fits all solution. There's a huge range in architecture, types of vessels, etc. Each solution must be thought out well, considering all the factors. So marine projects are niche projects, good margins, and composites could be ideal solutions for maritime due to harsh environment and corrosion. The applicable power range demands for maritime vessels can be from a few kilowatt to several megawatts. So hydrogen, a low volumetric energy density fuel, may not be ideal for a very long distance travel, being viable for inland or a short sea shipping instead. So hydrogen used for submarine and underwater applications are also being considered. So, but here, along with hydrogen, oxygen also must be stored together. They combine, produce power and water. So global aviation industry is also gearing up to decarbonize. Biofuels and hydrogen play a major role as the batteries become far too heavy for aviation purposes. There are two categories currently employed for hydrogen use in aviation. First involves combustion of hydrogen as a replacement of kerosene in large aeroplanes, while the second employs hydrogen and fuel cell system for propulsion of small aircraft. Now, Zero Avia, a California-based startup in partnership with UK government's Aerospace Technology Institute program, completed first flight of a commercial-grade six-seater aircraft powered by hydrogen fuel cell. Again, recently, Zero Avia completed highly successful 20-minute flight test of Dornier 228 testbed aircraft at Cotswold Airport on 4th of April this year, confirming the reliable performance of hydrogen electric propulsion system. Now let's talk about the new development and research in Type 4 cylinder technology and manufacturing. As you're all aware, wet winding is already an established process, but tape winding has evolved very rapidly in recent time. There are areas for operational efficiency improvements in both the processes. The research is ongoing for improving the operational practices and to improve the production rate. Technology evolution provided by numeric control and automation has really transformed the filament winding. There are degrees of freedom of fiber guidance and manual motions. The introduction of industrial robots have greater control of process parameters as well as improvements in repeatability and manufacturing times. So there is ongoing research to improve production rates, improve problems with kinematic synchronization between the robot and other equipment. Then material selection or development of resins, thermoset matrices have historically dominated market for FRP, fiber reinforced composites. Uh, and However, utilization of fiber reinforced thermoplastics over thermoset based composites is gaining momentum. Manufacturing issues limit the widespread employment of thermoplastic resins as they tend to be more complex to process than thermosets, especially higher molecular weight and mild viscosities make their impregnation significantly more difficult. So there is an ongoing research to develop new techniques and new material systems for easily processable thermoplastics. Then recycling, circular economy is also a research area because the focus is on circular economy across the world. Research is ongoing for mechanical, thermal, and chemical recycling processes. The important aspect of hydrogen tank project is selecting a reinforcing overwrap for a liner that provides hoop strength. This is a key quality for high pressure applications that directly affect burst puncture resistance. Carbon fibers are uh, consolidated option due to their elevated specific tensile strength. But again, the cost is a major issue since the significant growth in demand for carbon fiber is expected. Alternative reinforcing fibers such as basalt fibers have been a key focus of R&D studies aiming at tank cost optimization. Then liner is a component whose function is to act as a mechanical barrier between the fluid and structural overlap. This prevents permeation from several microcracks that are present in the substrate of composite layers. So, plastic liners for Type 4 cylinders usually employ a thin layer of high density polyethylene or aliphatic amide, and optimizing liner shape is the first step to maximize the tank volume and minimize the total mass. So, there are lots of ongoing researches to develop new liner material which has less permeability and which are highly resilient to during tank charging and discharging without causing blistering or collapse. There are several hurdles during the commercialization of hydrogen tanks include minimizing cycle time in filament winding, then safe design, lightweight, low cost, etc. There's a lot of research to optimize the size of composite layup using composite laminate theory, netting analysis, design of dome geometry, then finite element analysis of design, modeling of winding layers, helical winding on geodesic, non-geodesic path, working pressure, cylinder dimensions, etc. So finally, as this field is evolving, there are significant possibilities in testing techniques again and for certification requirements. So Scotland and the UK can really help you in all these research areas as discussed earlier. We have excellent ecosystem and research equipment as well as the skill sets to design and optimize Type 4 cylinder manufacturing. Their specialized knowledge of materials and modeling capabilities will be helpful in developing new materials and optimizing the cylinder design. We have National Manufacturing Institute of Scotland, which is with the University of Strathclyde. They will help you in developing your own optimal automated and advanced manufacturing processes. Now, University of Bristol recently developed a cryogenic composite cylinders for hydrogen storage. So, working with Scottish and UK-based research institutions can greatly help you in your ambitions for manufacturing Type 4 composite cylinders in India. So, feel free to reach out to me if you're interested to work with these any of the above universities or institutions or anything. So, in conclusion, the world over, governments are promoting hydrogen to use to reach net zero targets. Hydrogen storage using Type 4 composites has huge growth potential. The near-term opportunities are with heavy vehicles, railways, maritime. Opportunities will open up for LCVs and passenger vehicles as hydrogen infrastructure is created. And there are many opportunities in research in composite cylinder technology for hydrogen storage. Scottish and UK universities and institutions are well placed to support you in your Type 4 cylinder manufacturing for hydrogen storage in India. I would like to credit these resources for my presentation materials and speaking notes. And thank you very much, everyone, for patiently listening. And thank you, organizers, for giving me this opportunity to speak. I'm very much.